We'll be talking about function values in this video on page 150 of the textbook. So function values and function notation. So equations that are functions can be written in a form called function notation. Okay, so if we have an equation, y equals 3x minus 8. Two variables, trying to find our x component of our ordered pair and the y so we can then plot it on a graph. So we have our y equals 3x minus 8. That's the equation. Now let's talk about this in terms of a function. The way we write that is f open parentheses x close equals 3x minus 8. These are exactly the same things. So the x represents the independent quantity, or the elements of the domain. So that's what our x represents. And then the y, or the f of x, same thing, represents the range or the dependent value of this, or quantity of this equation. So what does that mean? What it means is basically like a machine. Whatever you put in for x will determine what your y is. So that's why it's dependent. Whatever you put in for x will determine your y. So that's why we call it a function of x, or f of x. That's how we read that. F, open parentheses, x, close. F of x. Okay, so what does this mean? How do we deal with this? Okay, so if we want to find a value for y, or our f of x, for say the number 5, we can put that in. So we say, okay, in this equation, or this function, f of x equals 3x minus 8, what happens when we put a 5 in, when x equals 5? So let's put it in, see what happens. So we have f of x, and when we put an actual number in, we write that f, open parentheses, 5, close parentheses, equals 3, open parentheses, 5, close, minus 8. So that's f, x equals 5. So any place you see an x, you dump that 5 in. So f of 5, or f open parentheses 5 close, equals 3 open 5 close minus 8. Now all we have to do is solve the right side. So we can say f of 5 equals 3 times 5 is 15. 15 minus 8. So f of 5 equals 7. So our function f of x equals 3x minus 8, you'd get an ordered pair. So when you put in 5, so open 5, comma 7, close. So that's where you would plot that on a graph. So you're just chugging, you're just throwing numbers into the machine, coming out with your y value. Let's try another one. So this time we have f of x, so f open, x close, equals 2x plus 5. And now we need to find each value. So this is again example 3, page 150 at the bottom of the page. So part A of this, using this equation, this function, says find f of negative 2. So A says f open, negative 2 close. So that means wherever you see an x in our function, throw in that negative 2. So we'd write that as f, open parentheses, negative 2, equals 2, open, negative 2, because it was 2x originally, plus 5. Okay, so now we solve. This on the left, this f of negative 2, we don't do anything with that. It's just telling us what we're solving for, so you leave that alone. So we have f of negative 2, or f open, negative 2 close, equals 2 times negative 2, which is negative 4, plus 5. Do our last step. F of negative 2 close equals 1. Negative 4 plus 5. So that's our answer. So f of x equals 2x plus 5. When we dump in a negative 2, your f of x value or your y value or your range is 1. And we could write that as an ordered pair of -2, 1. Okay, now it's going to get a little bit trickier. Putting in for part B, so we have f of 1, so f, open parentheses 1, close, plus 4. What does that plus 4 mean? It means we put this 1 in for a function and solve for that, and then add 4 to the end of it. So what we do, again, is wherever we see an x, we put this 1 in. So we get f of 1 equals, and we write this as open bracket, because we're solving for the f of 1 first, 2, open parentheses 1, plus 5, because our original function was f of x equals 2x plus 5. So now we have f of 1 equals, open bracket, 2 times 1 plus 5, close bracket, plus 4 at the end. So you just add that plus 4, just tack it onto the end of the equation of your function. Okay, now let's solve for this. Inside the bracket first, remembering our order of operations. So we have 2 times 1 plus 5. So now we have f of 1 equals 2 plus 5 is 7, plus this 4 we had tacked on at the end. So now we have f of 1. We have f of 1 equals 11. So when we put in f of 1 plus 4, our answer is 11. And we write the ordered pair as 1, 11. This is example 4, nonlinear. So we have nonlinear function values. Okay, so what does nonlinear mean? Nonlinear means you have an exponent. So example 4 is talking about physics. The function h of t, so we don't always have to use f of x. We can use different variables. You have h of t in this instance, because the variable throughout the equation is a t instead of an x. So h of t equals -16t squared plus 68t plus 2. And what this represents in this equation is the height, h of t, of a football in feet t seconds after it is kicked. So h of t is how high a football is after a certain amount of time in seconds. So find each value. So h of 4. So the height is 4 feet. So this is part A. So we have h of 4, so h open parentheses 4 equals -16 open parentheses 4 close squared plus 68 open 4 close plus 2. So every time we see a t, we're replacing it with 4. And sorry, the t is seconds, not, we're trying to find the height. So the t is seconds. So now let's just plug and chug and solve this. So again, we have h of 4, that left side doesn't change. And we have -16 times 4 squared. So we have -16 times 16. So that gives us -256 plus 68 times 4. 68 times 4 is 272 plus that 2 that's just hanging out there on the end. So we have -200, or h of 4 equals -256 plus 272 plus 2. So on the left we have h open 4, or h of 4, equals 18. So after we add all those three numbers up, what we get is 18. So what this tells us is that at 4 seconds, The football is 18 feet in the air. We could plot this on the graph and just watch the trajectory of the football as it sails through the air.